Okay, the fourth article, that is the interpolation now. Weightage of this topic is again 5 marks. There are total 5 methods that we have. Out of that 5 method, the question will come only on one method, and that is for 5 marks. In last 4-5 years, the questions only coming on forward interpolation, backward interpolation, and Lagrange's one. So these are the most important method: forward interpolation, backward interpolation, and Lagrange's interpolation. There is not a single question in last 4-5 years on these two methods known as a central interpolation and divided interpolation. So yes, we are going to complete each and every method, but you should focus on these three methods mainly: forward, backward, and Lagrange's. With the help of that, we can solve any question actually. Central and divided interpolation are optional methods for the same purpose. Okay, so because of that, actually they are not coming in the exam. That may be the reason. But yes, these are a few more methods for interpolation purpose. Now, before we start this topic, let I tell you the meaning of interpolation. Actually, this interpolation is a process. This is a process by which we are finding the values of y for the given values of x. It is not like a missing values. It is not like a missing values from the table. Okay, when we have to find the missing values from the table, yes, simply we use a difference table and we can get that missing value. We already seen in the last session. But here the question is a little different. Suppose we are given x and y like this. Suppose x takes the values like 1, 2, 3, 4, and corresponding fx values you are given like 2, 9, 15, and 21, something like that. So when x is 1, y is 2, when x is 2, y is 9, and so on that way. And now question is, what is the value of y? What is the value of y? What is the value of y when x is equal to, say, 1.5? X is 1.5. So at x equal to 1.5, what is the value of y? That we have to find it. And this process is known as an interpolation. This process is known as an interpolation. So we are finding the value, functional value. We are finding the functional value on intermediate points in the range of x. So range of x is in this case is 1 to 4. So in that range 1 to 4, we are finding the value of y. That is the interpolation. Is it clear? So throughout this interpolation topic, we are going to find the functional value at a given value of x. So let me start. Today only we'll see one method, forward interpolation. So for forward interpolation, this is Newton's Gregory forward interpolation formula, okay, or forward difference formula. You can. So first step, you should by heart this formula. You should remember this formula. This is the interpolation formula, where we are interpolating at a plus xh. We are finding the function value of a plus xh. So f of a plus xh is equal to f of a. Actually, this is a similar formula. If you go with this one, x f of a plus x f dash a, but there is x square upon 2 factorial f double dash a. So that is there. So x square by 2 factorial f double dash a plus this is actually probably Maclaurin series or the Taylor series that way, but it is not that way. Now here there is a difference. F of a plus xh is equal to f of a plus x delta f of a. Actually, this is just like xc1. This is just like xc2. This is just like xc3. Okay, what is xc2? xc2 is x into x minus 1 upon 2 factorial. What is xc3? X into x minus 1 into x minus 2 upon 3 factorial. So this is a combination tricks there that you have. So that way only. So these are the terms. There is some symmetry. You should remember this formula. Okay, only formula mainly is important for interpolations. So that about the derivation is not required again. We are not going in derivation of any of these because that's not coming in exam. Only numericals are there. Let I show you one question here on interpolation first. This is the question number 1. You will observe in the first question we are given x and y values. We are given the values of x and values of y. The question is says x is nothing but it is a distance in nautical miles, and y is the height, corresponding height, and we have to find out the height for the distance 120, for the distance 120, as well as we have to find out height for the distance 218. In final examination, generally you don't have to find the values of fx at two different points. Only one will be asked, either 120 will be asked or 218 will be asked. Okay, so this is just for practice. The two values are given here, but in examination we have to find the functional value at only single point. Our aim is to get y when x is 120, or we have to find out f of 120. We have to find out f of 120 there. Now to get these values, we have the step number one as a difference table. Step number one, just make a difference table. So I will show you here a difference table. The first column is x, next column is f of x. This is actually y equal to fx. This is x and y equal to fx. So these are the given values only. Start with 100 up to 400. So here is 100 up to 400. These are the x values, corresponding given values of fx. Now this difference is calculated. This we learned in the last session only, how to get a difference. Like this minus this, you get this value. Okay, this subtract 10.03 minus 10.63 is a 2.40 and so on. This subtraction gives you here. Okay, these two subtractions. So that way. So step number one, make a difference table. Now we start with a formula. What is our formula? Yes, anyone tell me? Forward interpolation formula, f of a plus xh. Let I write it here. F of a plus xh is equal to, by Newton's forward interpolation formula, f of a plus xh is equal to f of a plus x delta f of a plus x into x minus 1 upon 2 factorial delta square f of a plus x minus 1 x minus 2 upon 3 factorial delta cube f of a and plus so on. So this is the Newton's forward interpolation formula. Okay. Now with the help of this formula, we can find out the functional value at 120. Okay. So obviously we want functional value at 120. So what should be the value of a plus xh? So these are the important steps now. What should be a plus xh here? Yes, anyone? Yes, we have to find out the functional value at a plus xh. So what is that value there? Someone is on the chat. Let I check. Yes, someone is given me as a as 100. That is okay, but I'm asking what should be a plus xh here?
120.
Yes, obviously 120. We have to find out functional value at 120. So let a plus xh is 120. Good. Now when a plus xh is 120, you are observing how you get a plus xh is 120. You are adding something xh in a, then you get 120. So a should be smaller than 120. A should be smaller than 120 because plus xh is there. Plus xh is there, provided both x and h are positive. Okay, so a should be just below of 120. A is always just below of 120. So if you see the table in the values of x, 120 comes here. 120 comes in between 100 and 150. So just below 120 is 100. So a should be 100. A should be 100. Is that clear? If a plus xh is 120, a you have to take just below that. So a is 100. Now what is h here? What is the value of h? H is a class interval. It is a difference between two successive values of x. So what is h?
20 by x.
No, h is a 50. You will observe 150 minus 100 or 200 minus 150. You will observe the difference between two successive values of x is a constant, and that is h is a 50. 50. Now, when you have these three values, we can find the value of x. So what is the formula for x now? So x is equal to 120, this 120 minus a divided by h. Now we have 120, the value of a is there, the value of a is 100, 120 minus 100 divided by 50, and what is this number?
0.4.
0.4. Yes, correct. So x is the 0.4. Now the last step is left here. Whenever we take a as 100, the corresponding row is known as a leading row of the table. So this is a is 100. A is 100, we already taken. So this is f of a. This is delta f of a, delta square. So in this table, we are mainly interested in this row only. These values are very, very important for us. So that mainly we are going to use it here. Okay. Am I audible? Because just network issue is there.
Yes, sir, audible.
Okay, okay,
Now you're audible.
okay. So last step is left now. We have to just replace these values now. We have to replace all these values in this formula. So let me start. Let me replace these values. So a plus xh is 120. So I'll write f of 120 equal to f of 120 is equal to. What is the value of f of a? Yes, anyone?
10.63.
Very good, correct. This is f of a. Then x, the value of x is 0.4. So I'll write 0.4. What is delta f of a?
So 2.4.
2.4.
2.40.
Correct, very good. Plus x into x minus 1. X is a 0.4. X minus 1, that is 1 minus 0.4, that is minus 0.6. Is it? So here we are replacing x is 0.4. 0.4 minus 1 is minus 0.6 upon 2 factorial upon 2. Just I will erase this one step here. All right, here only 0.4. Okay, so into delta square. What is delta square? What is delta square f of a? Minus 0.39. Is that? I'm not getting any answers. Internet there. Okay, so this is delta square f of is a minus 0.39. Is that okay? Am I audible?
Yes, yes.
Okay, good. So, can anyone tell me what is the most important thing is happening in this series or in these terms? The observation is very important. What is the important thing that is happening in each terms there, in each next terms?
Less value, sir.
Less value. Okay, good observation. So 3 factorial is 6 and delta cube is 0.15. So the most important thing you should observe, 10.63 is the first term. If you take zero point 0.4 into 2.40, this term is a very small comparative to the first term. If you move to the next, this again becomes a smaller, this becomes a still smaller. So when you move away from the first term, that all consecutive terms becoming smaller and smaller, and they are negligible. They are negligible. Right now you will observe in this sequence, up to delta cube, these values are reasonably large, but these values are still very smaller. They are already a small. With this coefficient is a small, then there is no need to compute the calculation up to delta 6, because even though you calculate the calculation up to delta 6, your answer will not change. You will get the same answer. This 11 point, if you simplify this calculation, some of you can try, you can just add first, second and third term, you get this answer. Okay, if you first, second, third and fourth term, then also you are going to get the same answer. Okay, so generally it happens that you should do a calculation mainly up to delta cube, third difference, because the higher differences are generally a very small. Okay, this is depending on the difference values. If difference values are larger, you cannot ignore it. Remember, you cannot ignore the higher differences provided they are in large number. Right now they are negligible, 0.07, 0.02, 0.02. So because of that, these no need to take these in calculation. Okay, and this ignore part, that is only applicable in forward and backward interpolation. Okay, you can ignore some differences provided they are very small in forward and backward only. Any doubt in the first part, getting f of 120? Okay, if you don't have any doubt, can I move to f of 218? Now we have to calculate at 218 also.
Sir,
Note
please
down.
2 minutes.
Yes, okay, if you want you can note down. So indirectly we are predicting the value of fx at 120 by interpolation, by the method of interpolation, and that where we are actually approximating the function by a algebraic polynomial. Can I erase?
Yes, sir.
Now come to the second part of the question. Now we have to find the functional value at a 218. Can anyone tell me what is the value of a plus xh? What should be a plus xh now?
218.
That should
218.
be 218 itself. Very good. What should be a now?
200, sir.
200. That's good. So you'll observe 218 is coming here. 218 is coming here in between 200 and 250. So just above is a 200. So a should be 200 now. So what is h again? H is here 50, 50. H will not change. What should be x now?
0.36.
0.36, correct. So if you do this calculation, you will get h as a 0.36. Now, which is the leading row now? Tell me the value of f of a. What is f of a for the second part? This value,
15.04.
correct, very good. What should be delta f of a?
1.77.
Very good, 1.77. Delta square,
Minus 0.16.
very good. So this is the leading row now. These values we require in the calculation purpose. So when we calculate this f of 218, f of 218 is equal to f of a. The f of a is a 15.04 plus x. The x is 0.36 into delta f of a, that is 1.77, plus x, that is 0.36 into x minus 1. So it may be minus 0.64, is it? Minus 0.64 divided by 2 factor, that is 2 into delta square, so minus 0.16. That's one. Now I'm not going to do the calculation with these two because they are again negligible, they are very small. So with these three terms, this plus this, you will get the answer 15.7 only. Is that clear? How to get that f of 218? Yes, Risham, you are correct. Can we move to the next question then? Can we move to the next question?
Yes, sir.
Okay, good. So question number 2 is completely solved here. You will observe we have to calculate a functional value at 1.85. The question is find 1.85 value of y at x equal to 1.85. So what should be a? Obviously it is highlighted here. Okay, so as we have to calculate at 1.85, a is 1.8. Then what is the a plus xh is this one. A plus xh is 1.85. A is that. What is h here?
Zero
Point
0.1.
one.
Point
0.1,
one.
that's
Point 1.
correct. Okay, and remaining is just a calculation. It is complete solved question here. You can go through it to your own later on. So everything is given. A is 1.8, a plus xh, h is 0.1, and just forward interpolation formula. You have the answers there. Okay, you can do it. You can go through that solved example because this PDF is with you. You can go through it. Question number 3 now. Now, what is the difference in the first two and this third question? The difference is in this case, we know the function whose value we are calculating. Actually, in question number 3, we are given sine 45, sine 50, sine 55, sine 60. Okay, and the question is find sine 48. Now, the best part for you is the answer is with you now. On a calculator, just press sine 48 in a degree mode only, and you get the answer. And you should get the same answer or exactly approximately equal to that by a finite differences. Now here by the method of interpolation, we are calculating sine 48, even though we know the function. Okay, that's only the difference. So difference table is prepared. 48 is just below 45. So a plus xh is 48, a is 45. This is the leading row. Calculation is done with the Newton forward interpolation, and we get sine 48 as 0.7431. Any doubt in the first three questions?
No, sir.
Okay, because they are straightforward question. If you got one question, remaining are similar only. Okay, so only small changes may be there in calculations. Now, can anyone tell me what is the difference in the first three and this fourth question? I want a difference. This is the fourth question on the screen here. What is that difference?
Sir, here we are directly given the f of values.
No, that is in the previous also. We are given x values and y values. Indirectly, we are given x and y values, no? So that is the same thing in previous questions also. But what is that difference that you will observe in the question? In previous question, we have to just find functional value at one point. Okay, that is only there in previous question. But here we have one extra part, and that extra part is find interpolating polynomial. Find interpolating polynomial also. So we have to find out general function fx first, general function fx first, and then using that we have to find out f of 0.5. So step number 1, we should make a difference table. So step number 1, we should make a difference table. Okay, so only small changes may be there in calculations. So So we have this x, we are given y. What are the values of x? X takes value 0, 1, 2, 3. 0, 1, 2, 3. What is the fx values? F of x values are like 1, 0, 1, 10. Then we calculate delta. This is 0 minus 1 is a minus 1, 1, 10 minus 1 is a 9. That is the first delta square now. 1 plus 1 is a 2, 9 minus 1 is 8, and delta cube is 10. Any doubt in the difference table? So step number 1, we write a difference table. Now we start with that formula. What is the formula for interpolation? We say f of a plus xh.
Delta cube 6 na sir.
6 delta cube.
Yes, my mistake. Correct. Very good. So this is 6. This is 0, 6. Okay. So that is 6 is correct answer, delta cube. So f of a plus xh is equal to f of a plus x delta f of a plus x into x minus 1 upon 2 factorial into delta square f of a plus so on. So this is the formula that we have. Now here we should from this one we have to just calculate fx first. So can you tell me what should be a and what should be h here to get that polynomial? Generally the a is always the first term of the table because it gives us a maximum differences and we get a better approximate polynomial. So here the initial row of the table is this one. So what is a? A is equal to 0. A is a 0. What is h? H is 1. And that value is only we have to replace because we want fx first. So if you replace a by 0, h by 1, this equation will become fx equal to f of x equal to. What is f of a? F of a is 1 plus x as it is. Delta f of a is a minus 1 plus x into x minus 1 upon 2 factorial is 2. Delta square f of a is 2 plus x into x minus 1 into x minus 2 upon 3 factorial means it is 6 into 6. And now just you have to simplify this, you get fx first. You will get fx first, and that fx is nothing but it is a interpolating polynomial for that given data. Okay, so this is the extra part that is asked in the question number 4. Okay, you don't have to substitute the value of x first. Without that, you have to find out function fx first, and then at the end you replace x by 0.5. X by 0.5, you get f of 0.5 there. Is it clear? I will show you this solution. The solution is on this page. You'll observe this is the difference table first. With this difference table, fx you get here x cube minus 2x square plus 1. When you simplify term by term, multiply and simplify, you get fx there. And now you replace f of 0.5. You calculate f of 0.5 there. If there is any doubt, yes, you can ask. So can I move to the last question then? Last question for today. If you don't have any doubt.
Sir, what is the answer of this question?
You can check it now. 0.5 cube minus 2 into 0.5 square plus 1. So that will be the answer. What is 0.5 cube?
0.125.
0.125. 0.5 square is a 0.25 into 2. Is it minus 0.50?
Sir, can you please
Yes, sir.
explain after f of x we...
So just you have to simplify this now. You get this answer. Here is that.
Yes, sir, then.
And then you have to calculate f of 0.5. Replace x by 0.5 on both sides. F of 0.5 equal to 0.5 cube minus 2 into 0.5 square plus 1. And this will be your answer.
Okay, sir.
Okay, there is one similar question. You can do it your own. Question number 5, that one. Last question for today. Our aim is to get the number of, see the question first. From the following table, estimate the number of men getting the wages below rupees 15,000. And we are given a table of wages versus the frequency. Means the number of men having the wages between 0 to 10,000 rupees are 9. Number of men having the wages in between 10,000 to 20,000 rupees is a 30, and so on. So that is given, and we have to find out the number of men having the wages below 15,000 rupees. Can anyone tell me how to convert this data from group to the ungrouped form? Actually, we don't want that 0 to 10 implies 9. We want some x which gives us fx there. So what should be the values of x? The corresponding, these values gives us y there, or because interpolation works for x and fx there, not x should be the single value, it's not a interval. So step number 1, we have to make the table here. The table will be of x and y. Yes, what should be the values of x there?
Zero.
Average value, sir.
Pardon?
Average value.
Average. Okay, you are taking mid values there. So not correct actually. 23 is again giving the same answer. Mid values. Actually,
Zero.
it's not 0 again. We take the values of x like the upper value, and we give the meaning to the x as number of men getting the wages below x. Number of men getting the wages below x, and now below x, first we take 10, 20, 30 and 40. So we have 10, 20, 30, 40 as the values of x. Now how many men are getting the wages below 10,000?
9.
9, correct. How many men are there whose wages are below 20? How many men are there?
39.
39 is the correct answer. Good. Similarly, how many men are having the wages below 30? So it is, I think, 74. 39 plus 35. And lastly, below 40 are, I think, 116. Is it? So just you have to add these one. So why we are taking below? Because the question is that way only. We want the number of men having the wages below 15. Below 15 we want. So we take below 10, below 20, below 30 and below 40. Okay, so that way we converted. It depends on the questions only. So we get a delta now. Now delta are the first order difference. 39 minus 9 is a 30. So we get 30, 35 and same 42 as a first order differences. Then we get a delta square 5, 7 and delta cube as a 2. So these are the differences. And now can you tell me what is the value of a plus xh here? What should be a plus xh?
15.
Very good. That's correct answer because we want below 15,000. What should be a?
10.
10. What is h?
10.
10. Correct. And now you can complete your answer because this is a. This is the leading row. A, f of a, delta f of a, delta square f of a, delta cube f of a. And you cannot ignore any of the term. Remember, you cannot ignore delta cube also because it is not a small number. It is 2 there. It is not in fraction. So do the calculation up to delta cube f of a. And suppose your answer, if you take f of 15 at the end, suppose f of 15, you are getting something like 15.7. Suppose you are getting 15.7. So you can say approximately 16 men are there whose wages are below 15. So you have to approximate that fractional to the nearest integer because we are writing as a number of men here. So number of men are roughly the 16 who are getting the wages below 15 that way. Am I clear?
Yes, sir.
Okay, so that about your last question then. If you have a doubt, yes, you can ask.